everyone, and welcome to lesson 4.2, day 1. Today we're going to talk about the side lengths of isosceles triangles and properties and theorems of isosceles triangles in order to solve problems. So what exactly is an isosceles triangle? Well, it is a triangle with at least two congruent sides. So again, at least. Now normally you'll see just two. Those are called your legs, and again, they are the congruent ones. And then you have a base side that's not necessarily congruent to the other two. The side opposite of its angle, this angle across from the base, is called the vertex angle, right? It's touching the two, it's made up of the two legs. And then the other two angles that are on top of the base, those would be called your base angles. Again, those are opposite of your two legs. Now, in an isosceles triangle, again, we have at least the two congruent sides. And the isosceles triangle theorem basically says that if you have two congruent sides, their opposite base angles are also going to be congruent to each other. So if we have legs AB and BC congruent, angle A and angle C are congruent to each other, not necessarily the vertex angle. And then the converse of that is also going to be true. If our two base angles are congruent, then the sides are also going to be congruent. So you have to see if this happens, then this happens, and then vice versa also works. If we have the base angles congruent, then the sides are congruent. So we have to be careful each time. Are we talking about the angles or the sides? So we know what is going to be considered congruent. Now, reminder from our previous units, our previous topics, triangles sum the interior angles to equal 180 degrees for their interior angles. So we have all three interior angles always add up to equal 180. This is a fact that we're going to be using today because when we have an isosceles triangle, it says the measure of the vertex angle in this particular isosceles triangle, so we know those are congruent, base angles are congruent, they're telling us is 110, and we want a measure of what one of the base angles would be. Well, again, if we know there's 180 degrees total, and we're taking up 110 degrees with that vertex angle, we're leaving 70 degrees to be divided up between those two angles. Now, because they're congruent, we can divide them up evenly so that each one is 35 degrees. So our final answer on that one is that each base angle would be 35 degrees. On the flip side, if they give us one of the base angles of an isosceles triangle, again, we know those base angles are congruent in our isosceles triangles. So one of the base angles they're telling us is 30. What would the measure of the vertex angle be? Well, again, we know the other base angle is congruent, so it's also 30. And then 180 minus 30 minus 30 gives us 120. That would have to be the measure of that vertex angle up top. So I really recommend drawing a picture to help you solve. And there are 2 example problems of that for you to try on your own. Now, down in the next example, notice they only marked these 2 base angles congruent. So we do know this triangle is isosceles because, again, if those base angles are congruent, we're allowed to talk about our 2 legs being congruent as well. Each time I like to mark all of these pieces of information. Now, notice this time the placement of our expressions with x, they're on the outside. So they're talking about not the angles, but the side lengths. So in order to set up and solve for x, the first thing that we're going to do is we're going to take the two congruent legs, 10x minus 45, and we're going to set that equal to 8x plus 15. Right now, this base angle is just extra information that we're not using at the moment. Okay, we need the 2 congruent pieces. So we're going to move across that equal sign. So we'll start by subtracting our smaller x value. And then to get our x's by itself, we're going to want to start then by adding the 45 to both sides to get our 2x alone. And then last but not least, if we divide by 2, our x value is 30. So that's part 1, solve for x. The second piece then is asking us to find the value of the base. So this is where the 55 minus x comes in, because if we subtract 55 minus 30, we get our remaining value of 25 to be the length of that base. On the top of the next page, we have another example. Notice this time they marked the sides congruent, so we know it's an isosceles triangle. I'm going to mark the angles congruent as well, so I don't forget that those are congruent. And as I start reading through the information, notice they're talking about the angles. They're telling us information about angle A being 6x minus 42. Then they're telling us angle B is 2x plus 16. And we want to solve to find the value of x. Now, the problem is our vertex angle isn't necessarily equal to these two base angles, right? It's usually something different. And we don't know currently what the two base angles are to set those equal. But what we can say is that because we know angle B and angle C are congruent because they're the base angles of a isosceles triangle, we can say that that is also going to be 2x plus 16. And then we know that our three angles have to add up to equal 180 degrees total. So we could take those three expressions, add them up, and set them equal to 180 to get our final answer. Now we're going to want to condense 6x plus 2x plus 2x is 10x, negative 42 minus 16, or excuse me, plus 16 plus 16 more is negative 10, right? Negative 42 plus 32 is negative 10. So then we can add that 10 to both sides so that we end up with 10x equals 190. And then when we divide by 10, x ends up equaling 19. And again, this time they just wanted us to find the value of x. We did not have to plug it back in. All right, so on the next example, it's a U-try. They want you to determine the length of AC. First, though, you are going to need to solve for x, and then you will plug it back in to find the length of AC. I recommend labeling. Notice they're talking about side lengths. Labeling your picture to help you decide what you should set equal. All right, last but not least for today with these isosceles triangles, we have one more theorem. And basically what that theorem states is in an isosceles triangle, if you have a segment that bisects your vertex angle, what's going to happen is it is going to become the perpendicular bisector of that opposite base side. So A to D will be congruent to D to C, and we are creating a right angle right here. So if you have this set up, you are allowed to draw in that perpendicular bisector. So how are we going to use that in this example? Well, notice again, they give us that setup. We notice that angle ABD and angle CBD are congruent. They're showing that bisected, those tick marks. And we also know it's isosceles because AB and BC are marked congruent. So we're allowed to also mark on our picture then that these two angles are, or two sides, are congruent. And we're creating right angles inside those two smaller triangles that are divided up. Now the next piece then in this example says that angle CAB, so this angle right here, is 58 degrees. And we want to find the measure of angle CBD. Well, reminder, angle CBD is going to be the same exact value that angle ABD is, because notice up here again, they were showing the tick marks, they were bisected. So if we focus on this triangle right here, we basically have two out of the three angles, right? We have that angle D is 90, we have that angle A is 58, and we can find our last remaining angle up here by doing 180 minus 90 minus 58. So again, if we take 180 minus 90 minus 58, we get 32 degrees. And again, these two angles are congruent. So if angle ABD is 32 degrees, so is angle CBD would also have to be 32 degrees. So our final answer on that one is 32 degrees. Now using this same photo, okay, this same picture, this time they're telling us about side lengths. Notice we don't have any angle symbol. We're being told about side lengths. This time they are telling us that side AB is 80, side AD is 48, and we want to find the length of D to B, okay, the height of this triangle. Well, again, we know that this was the perpendicular bisector, so this is a right angle. And when we have this right triangle, we have 2 out of 3 sides. We're given the hypotenuse, and we're looking for one of the two legs. So reminder with Pythagorean theorem, c squared equals a squared plus b squared. This time we have the c squared. What we don't have is either a squared or b squared, right? We're missing one of the legs. So we can subtract from 80, 48. Okay? So if we take 80 squared minus 48 squared, x squared equals 4,096, and we will square root that answer to get our final side length of 64. So again, don't forget that when we have x squared, we will need to square root to get our final answer here of 64. All right, down below, all right, we have a similar setup happening. This time they are giving you angle ACB is 44 degrees. They want you to find two things. They want you to first find the measure of angle ABD and then the whole thing, angle ABC. And then in the second piece, they want you to use that same picture. This time they are giving you that BD, the height is 56. They are giving you DC is 33. They want you to find the length of AB. Reminder, you can do that through finding BC as well. Okay, think about how you could do that. Thanks everyone for watching. We will work more with these properties and theorems in class.